In this video, we're going to look at how to find the length of a parametric curve. So first off, the formula, and here's the idea. So the length of a parametric curve, I guess let me write this down, will be the integral from some starting t value to some stopping t value of the square root of dx dt squared plus dy dt squared dt. Now, I don't think I put one up yet, but I will have later on a video up on why finding lengths of just regular old functions, not parametric equations. And it's a very similar reason for this, and the reason is the following. So if we have some curve, okay, so I'll just draw a little curve over here. So because, okay, so a little parametric curve. We'll just do this. Parametric curves do not need to be functions. Clearly we don't have a simple length formula from geometry for this, but when we look on a very small scale, so long as it's differentiable with x and y, then this will be locally linear. Okay, so it'll look like a line in there. And that line, as I look on a very small scale, has sort of a horizontal and a vertical part to it, and this would be some sort of delta x and delta y. And this length here would be the square root of delta x squared plus delta y squared, doing a little Pythagorean theorem. Now, since it's curved, and in many of our cases we'll see, there won't be many straight or any straight sections, then I won't have a perfect triangle of any finite length, but as these get infinitely smaller, this will get closer and closer to being a straight line, so that's where instead of having delta x, we have a dx dt, and instead of having a delta y, we have a dy dt, and instead of having the delta x here, delta y here, dx dt, dy dt, from whatever my starting point is to whatever my stopping point is. One more thing to say before we see a quick example. Most of these, I'll write down, most will need a calculator to evaluate. Now I put in quotes here, need. As you get more tools, you will be able to evaluate more and more of these integrals eventually without a calculator. But in a lot of cases, at least for the AP test, just sort of knowing this, taking the derivatives, putting them in, and typing in your calculator is good enough to give you all the points. The example I'm going to show, I don't need a calculator for, and we'll see what's happening here. So to do this problem, I need to take dx dt, which will be, of course, negative 5 sine of t. I need dy dt, which will be, of course, 5 cosine t. And I can just do the formula now. The length of the curve will be the integral from pi to 2 pi of the square root of dx dt, which is negative 5 sine of t squared, plus dy dt, which is 5 cosine of t squared. And if a decimal answer is allowed, I would oftentimes just type this into my calculator, press enter, and get an answer. But I can do this one without, so I'll show how to get through this one. So that's the integral from pi to 2 pi of the square root of negative 5 sine t squared is 25 sine squared t. 5 cosine t all squared is 25 cosine squared t. And in here, I can factor out the 25 because it's in both terms. And it's a constant I can factor it all the way out to the front, but as I bring it out, it has to come out through the square root, so I take the 25 out, the square root of 25 is 5, and I can end up with 5 times the integral from pi to 2 pi of the square root of sine squared t plus cosine squared t. And again, if you are allowed a decimal and you don't remember or don't know how to get through this, you could just type in the calculator. But I do remember that sine squared plus cosine squared is 1. So this gets us to 5 times the integral from pi to 2 pi of the square root of 1, which is just 1. And the antiderivative of 1 is t, so I have 5t evaluated from pi to 2 pi using the second fundamental theorem of calculus. Put in the 2 pi, put in the pi, so I get 5 times 2 pi minus 5 times pi, which is 10 pi minus 5 pi, which is simply 5 pi. Feel free to comment below if you have any questions. If people would like to see more examples, put a comment below. I can show some other tricky examples if you'd like to see them. And I hope this helped you out.